Good morning, ladies and gentlemen. Our task today is to have introduction in Discrete-Event Simulation tool, Extend Suite, and to obtain a basic knowledge in Discrete-Event Systems Simulation. Extend Suite is not a new one. It has a history around 15 years, but despite of it, this is an excellent tool to start a discrete event system simulation basics, and also it would be usable for more advanced applications simulation. Discrete event simulation as a simulation technology is based on some typical elements like queues with appropriate lengths, and these queues you should spend appropriate time. We know that we have a different queues based on different input-output principles. First in, first out, last in, first out, and also queues with a priority, which entities from this queue should be served first with a higher priority. So we have an income requests or entities. Entities can arrive with a different time frequency, with a different time interval between the requests. It means a frequency of arrival. It would be constant, it would be uniform, it also would be distributed in conformity with appropriate theoretical statistical distribution, like normal and other Bernoulli, Poisson, and so on, different distributions we have. After the queues, there are entity is served. It means simplest way it is just delay, time of delay. Also, this time of delay should be specified in conformity also with some statistical distribution. It would be constant, it would be uniform, it would be normal, or other. On such three main components are based discrete event simulation. So, our task is following. Our task is here. We would like to design the simple model of gas station, gas fueling station, small gas simulation station. And simulation time will be 1 hour. In the gas station, we will have one common queue of cars. In this queue will be the private cars, name it citizen. Also, we will have some special transport. We will name them ambulance. The private cars will arrive in gas station regularly, every 5 minutes. Special transport also arrives at the station every 15 minutes. Of course, regularly. We will simplify our task for the beginning. However, special vehicles, ambulance, have a priority over the vehicle's citizen. After this common queue, the cars should attend to fuel dispensers. One of dispensers is filled with a 95 octane gasoline. Second one is filled with 98 gasoline. 95 petrol filling time is around 5 to 7 minutes. However, refueling with 98 octane petrol is average 10 minutes with a 2 minutes deviation. Of all private cars, 80% use 95 gasoline, and the rest 20% of private cars use 98 gasoline. Ambulance, on the other hand, use only 98 octane petrol. Yeah, for first time, first opinion, something absolutely outstanding. Spaghetti. But let's see it step by step. What questions we must answer after simulation and during analysis of the simulation results? First, how many citizen and ambulance cars will be served at the filling station during 1 hour? What will be the maximum and average waiting time in the queue? What is the workload of the gas station? We must understand how profitable its business. And how many cars will be serviced by 95 gasoline dispenser, and how many cars will be serviced by 98 gasoline dispenser? Such an answers we must obtain of our simulation task. Now is the time to pay attention to our simulation tool. Let's see our simulation tool and pay attention to the desktop of the simulation tool. So, the simulation tool desktop is very simple. Extend Suite is launched. We have an upper menu where we have a menu file, edit, library, model, text, develop, run, Windows, help. We must start with opening a new model. Open. Because we have no model, nothing to open, but we have a new desktop for model design. So we will design the model with some name model2 mux. All the models in Extend Suite environment is based on some blocks. And blocks are stored in simulator libraries. Let's see what libraries we have. To design with a model, we need at least one library, utilities links. But we will open some more libraries, like Discrete-Event library, open. And we will open one more library, MFG library. Maybe it will also be necessary. such true libraries. To be more convenient, it would be reasonable to see the libraries on the right part of the screen. So let's see. We will open library window, and then we will see one of libraries here. Now we are ready to start. We have a libraries, we have a blocks, we have an open empty desktop, and we can start solve our task. To launch any model, first block which is necessary to use in any model, this is executive. Perhaps we can imagine it like some simulation clock. Always it must be located, deployed in the left upper side of the desktop. Oh, we have an executive. Now we are ready to design the model. What we will start? First we will start, because we're working with the generators and we're working with the queues and we're working with the service units. First we must design the queue of cars. First of all, we must design the generator of the entities, generator of the cars. Then we must design the queue, and then we must design some dispensers like service units. Okay, remember, we have two kinds of entities or two kinds of cars. First, we have a citizen cars. Okay, let's try to do and design. Let's try to create some citizen cars from Discrete-Event library. So we must find such one like generator of entities. We take it from library and put it on the screen somewhere here. Okay, this is our generator. We can mark it with appropriate text. Citizens. It would be reasonable to increase the text size. Much more better, citizens. And also we need one more generator. One more generator for special transport. This is generator. Yes, this is generator. Also, we can put it on the screen. Now we mark it with the text. I will copy the blocks. It must be much more convenient. Ambulance. Nice. Now we must tune the blocks and give them appropriate parameters in conformity with our task. What it was written. Citizen cars. Double click on the block. Now we must give the distribution. Arrival is this. Regularly, every 5 minutes. Regularly, every 5 minutes. It means constant. Every 5 minutes. 5 minutes. Okay. And also you can give some animation icon. No car. Where is our car? Car is here. Great. We are happy. At the same time, we must tune our generator for ambulance, and ambulance also arrives regularly, also constant regularly, but with 15 minutes interval between cars. I forgot to add some animation. Instead of green bubble, we will assign the ambulance car. Great. Generators are done. What else? My recommendation is, after that, to test or sample and to give a detailed insight in the simulation. It's reasonable to add some controlling units like counters in the queues, in the lines of the model, in the flows, to control the process. So we would like to add some model like count is here. Count, statistics, no, Q. Count model. We have some exits. Count items. Okay. We have a count items. Such one. We will put one element here. We will put other element here. Two counters we will add. And it is easy to connect together output of one block and input with the second block with the counters. So this is done. What else we need? In conformity with our rules, we remember that special cars, special vehicles, have an appropriate priority over the other vehicles, other citizen vehicles. It means we have a possibility to, a necessity to assign a priority of the ambulance entities. How it's done? This is done by block set priority, set, get. Where is set priority? Set attribute, set priority. Great. Set priority to this car. Opa. Also connect and change the parameters of this typical block. What we see here, we will assign to each car, to each ambulance car, priority 1. Okay, why not? This is done. In conformity with the rules of our task, we have a joint common queue. Let's start to insert in the model queue block. What queue we need? We need a queue with priority, because we assigned the priority to ambulance cars. And to arrange a joint queue, combine together two flows, we need a sum operator with the name combine. Let's start to combine. Combine. Attach it to queue. Attach it to here. Attach it to here. Or maybe it would be interesting to increase a little bit this or painting we would like to make bigger to be better visibility, to obtain better visibility. Okay. Nice. This really looks like better, I guess. What else? So, what we must know about the queue. Each queue has an appropriate length. Now we have a maximum length, 1000 cars, let it be. It's not necessary to do something more here. We will have very long queue, which will be absolutely enough for us for 1 hour simulation. Absolutely enough. So, we have two flows of cars, but we have a joint queue. And now we must distribute our joint flow. And remember that ambulance use just 98 octane dispensers, and however citizens use 95 and 98 octane dispensers. Now, first of all, let's design this fuel dispensers and like delay, like service unit, and then we'll go back to the previous situation. Okay. Where are our delay? Activity delay. Yeah. That's one. Copy block, because we have a two ones. Great. And mark them to be understandable that it is a real dispenser. I don't know. Okay, I can go back to normal size and then 98. $95. Okay, at least we have some two dispensers. Now a little bit make our figure bigger. Also attach counters for control needs. And now, perhaps at the same time, we can assign a parameters to our two dispensers in conformity with the rules. 95 number octane petrol filling time is in the range of 5 to 7 minutes. 5 to 7 minutes. It means random delay. And this is uniform distribution from 5 minutes to 7 minutes. Okay. Okay. Now we have a nice random generator. We will put it here. Okay, let it be. Okay, not so bad. And something like that we must do also with our other dispenser of petrol 98. But then filling time is average 10 minutes, plus minus 2 minutes. This is normal distribution. How it was written, 10 minutes, plus minus 2 minutes, okay. Normal distribution, normal distribution. This is done. Nice, looks nice. What else we can do with the octane dispensers? Nothing more, it's not necessary. What we can do? We can finalize. Final point of the model always is exit. So we can add an exit. Yeah, this is very strange that we started from the final end, but why not? Most of all, it's the result. So we must all outputs, we must attach to the exit block, but we must attach it to the exit block in ordered sequence. First, younger inputs must be used. Number 1, number 2, number 3. We cannot attach to this input because otherwise the model will not work. This is some specific. What else? So, and now we must design our main task, how to distribute, how to monitor, how to schedule our flows of the citizen cars and ambulance cars. We will do the following things. How to separate entities with a priority, mostly in this case, in this direction, and other cars which must go to the upper fuel dispenser. We will use such interesting mechanism like select block. Where is this one? Select, deselect, deselect, deselect. Maybe we'll have select. This is select. No, we need select that. This one. So, okay, nice place for that. From this output is coming entities to this input. Is okay. How about this block? This block distributes input entities in two directions, to A output and to B output. How to toggle the output? Okay, in conformity with our priority. Click on the block. We will use this select item. Top output, this output will be used if this selector will be 0. And 1 will be selected upper if this input is 1. If some another priority will arrive, then it will be discussed at the some mistake, and will be moved to upper direction, like citizen car. Mostly, yes, I guess this is done. And then we will connect P output with this selector. When in queue, when we will have in the queue entity with a priority, we will have a signal on this line, select line, and the gates perhaps will open. I guess. But to control this, I will put the block for counting on the screen. Library Discrete-Event. Where is my count block? This is my count block. And then probably I can go to this dispenser. Probably not, because the rules is that the dispenser should be attended not only by ambulance cars, but also should be attended also by citizen cars. So the question is not so easy. We must combine two flows. So we must use also such one block, like combine block. Okay, this is for combining. There is not necessary to some tuning of it. So it means that at least one flow will go to this octane. But then should be another flow from citizens. But remember that in conformity with the rules, 20% of the citizens use gasoline 98. However, 80% of private cars prefer gasoline 95. So we must once more split the flow. Let's take one more block, select D. We will put this one here. So first, citizen cars are going here. One part of cars going to 90, going for 98. Another part are going for 95. How? And now we must split two flows, 20 and 80%. This is possible. So we don't use this selector. So we have a probability 50-50. No, but we can use another way how to toggle the outputs. We will say that one of each of every 5 entities will use the bottom output. 1 of 5, it means 20% of the cars will go to the bottom, will go to the fuel dispenser or the gasoline 98. So, what we can do more here? I don't know. What else or next task? Pay attention to item run. Here, first we must specify initialize simulation setup. Simulation setup, we must say, first of all, time unit. Time unit will be minutes. We will have a discrete event simulation during 1 hour. 1 hour is 60 minutes. Start simulation, we will start with a first point, not 0. We will say OK. What else? Else, it is very interesting, we should generate report. Because after that, we can study the printed file and analyze the lengths of the queues, delays, and some other information. Therefore, we'll mark generate report and involve add alter report. So we will have add alter report, we will generate report, and practically this is all. You can run our model if you want. Pay attention to such features in the upper horizontal menu. There are the following regimes for monitoring of this simulation. This is turtle, velocity, this is slow, rabbit velocity, your model is running like rabbit, and then you can switch off or switch on your visualization. I prefer visualization. Okay, let's try to run the model. Yes, we will save the report. And now we look on our model. Our ambulance cars are coming, our citizen cars are coming. And we can see how the cars are going through the gasoline station and gas dispensers. Ambulance are going to 98. Citizens mostly are going to 98, but some of them, it means 20%, should go to 98. Here is some very important point that ambulance cars should attend just 98 gas dispenser. However, citizen cars could attend 95 and 98 dispensers. How many cars will arrive during 1 hour? Not so much, you see. In the left side of the window, we have some report. And what we can start and read it in also after the printing of this file, but also this is possible to see some ideas also in directly on the screen. What does it mean, activity delay? Activity delay. This is block number 22. This is block number 23. So what we see that utilization of this gas dispenser is around 90%. It means this one working all the time. This gas dispenser of 98 gas working not so much as the first one, but also 80%. This is also very good parameters. It means that our workload is very good, and practically we are close to the situation that some more one should be installed for fueling the cars. Our next interest point is the queue. You see the queue. So, how many cars arrived in this queue? 16. Departures, also 16. It means no cars in this queue. What else we can see? We can see current queue wait. It means you must wait, or maybe it's better parameter. Average wait in the queue is 2 minutes. This is not so much. This is normal. Average queue length is 1/2 of car. However, this is interesting that we must respect also maximum waiting time. Maximum waiting time should be around 7 minutes. No, this is not so. This is appropriate for some situations, but sometimes it should be long enough time. But no more than 2 cars. No, okay. More or less, we should be satisfied with this situation. Using this report, we can give an answers on the questions which are given in our task, for our task. But also we can analyze the parameters on the blocks. We can see that on our gas station arrived 12 citizen cars, 4 ambulance cars, okay. We see really that these 4 cars, ambulance cars, also passed the queue. But what we see more that of these 16 cars which are arrived on gas station after the 1 hour served is just 14. Where are 2 other cars? First car, and this is citizen car. This is definitely citizen cars, because just citizen cars can attend the gas dispenser 95. 1 is still near underfueling. But also fuel dispenser of 98 octane petrol also is busy. There are still 1 car. Perhaps this is ambulance. Maybe. Perhaps this is some citizen car. Maybe. Perhaps this is, most probably this is citizen car. This is citizen car, most probably. Yeah, because arrived at 12 citizen cars. Now we have a 10. It means 2 citizen cars must be 1 here and 1 here. So this is our main introduction in beginnings of simulation using not agent, but extend suite Discrete-Event Simulation modeling tool. This is just one of mechanisms how to route the flows. Another mechanism is similar, and this is based on attributes. This is something similar. So we have a versatile enough mechanism of prioritizing and routing of the flows, and practically any system should be designed, simulated, and analyzed using this extend suite tool. So, my dear colleagues, for first time, thank you for attention, and I wish you the best.